A graph is connected if for every pair of vertices there is a path connecting them. In other words, you can go from any one point to any other point. That's considered to be a connected graph. A graph that is not connected, hold your horses, is called disconnected. Crazy. So in this one, this graph here is considered to be connected because for any 2 points that I pick, I can go from one point to the other. So if I wanted to go from C to A, for example, I could say, I really wish I knew where my cursor was. I'm so sorry. C-E-A. Done. If I wanted to take a longer stroll, I can say C-F-E-C-B-A. That's fine too. But all it takes is one path for it to be considered fine. Sufficient, we should say. Now, if your graph is disconnected, the connected parts of a disconnected graph are called components. So here our graph is not connected. Remember, just because two edges overlap does not mean that there is a vertex there. So OS, that edge, overlaps EF, that edge, which means that there's no vertex there necessarily because it'd have to be drawn, and it's not. So we don't have a connected graph. There's no way for me to go from E to M, for example. So we do have connected parts. We have MOS, and then we have DEF. It's a joke. Google it if you have to. Anyways, so typically we want to have connected graphs. Now, what we're getting to, the big problem of the entire chapter is this thing called the traveling salesman problem. And in that one, the salesperson is going from house to house to house to deliver their wares, whatever they're selling. Most likely vacuums or encyclopedias. Maybe it's an encyclopedia that's also a vacuum. Anywho, the whole point of that problem is the traveling salesperson wants to minimize their time they have to travel. And this is what UPS and FedEx and all the delivery companies do every day, except for DHL. They like to lose your stuff. Anywho, I digress. Well, if you have a disconnected graph, meaning you can't go from one house to another house at all, like there's no way to get there, that's bad. So that's why we typically want only connected graphs, and that's pretty much the gist from here on out, is we only want connected graphs. Not to say we won't see a disconnected graph, but it's not going to be related to the traveling salesman problem. All right, very good. Okay, and before the next video, a very important definition. A bridge is an edge whose removal would create a disconnected graph. So a very basic bridge, if this is vertex A, and that was vertex B, and that was my graph, then this edge right here is considered a bridge, because if I got rid of it, whoop, whoop, then notice there's no way to go from A to B anymore. So that's bad, and I can't bring that back. Unfortunately, it's terrible. So please watch the video, Finding Bridges of Madison County.